Welcome back. We have to solve equations this time. Look at this equation. Those are three rational expressions in the equations. We have a fraction equals a fraction plus a fraction. We also have to check for extraneous solutions. That is, numbers that make the denominator 0, because then this equation would become undefined. Let's do extraneous solutions first. We have to factor the denominators to find extraneous solutions, also to find common denominators. So to do that, denominator here factors as x times x minus 1. If I can get it to right, there we go. This denominator becomes 2x times x minus 1. And x minus 1 doesn't factor, it just stays. What makes each of these factors 0? Because that makes denominator 0. That is what an extraneous solution would be, and what x is not allowed to equal. That's what extraneous solution means. What makes x 0? Well, if x is 0. What makes x minus 1 0? Well, if x is 1. What makes 2x 0? If x is 0. What makes x minus 1 0? If x is 1. What makes x minus 1 0? If x is 1. So my extraneous solutions are just 0 and 1. How about a common denominator now? Because by finding a common denominator for each of these fractions, I'm going to show you how it clears out fractions, so my equation is just normal, no fractions. The common denominator, I'm going to call it the CD, the common denominator, has to have a factor of x. These both do. This one will need it. Has to have a factor of 2. This one will need it. And that one will need it. And notice they all have a factor of x minus 1. So they all have a factor of x minus 1. We need a factor of x and a factor of 2. That makes the common denominator 2x times x minus 1. I want to show you how, by multiplying the common denominator times each numerator, we'll cancel out these denominators. I'm only multiplying the common denominator by the numerators. It's like making the common denominator over 1 and multiplying each fraction by this amount. The denominators will stay the same for a minute. So we're going to have this huge equation to write. The 5 that's already here in the numerator is going to be multiplied by the common denominator. So times 2x, x minus 1. But it's already still over x times x minus 1. And now equal to, well, we have a factor of x plus 4 that's already there, times the common denominator, 2x, x minus 1, all still over the denominator that's already there, 2x, x minus 1, plus x that's already there, times the common denominator, 2x, x minus 1, over what's already there, x minus 1. Watch what happens. I have x and x. Those will cancel. X minus 1 and x minus 1 will cancel. If you cancel those out, what you have left is 5 times 2. What's that? 10. Equals. Here, I have a 2x and 2x. X minus 1, x minus 1. Those will cancel, leaving me with x plus 4. So it's equal to x plus 4. The third fraction, I have x minus 1 will cancel. That's going to leave me with 2x and x to multiply. Multiply those out. So cancel out x minus 1, multiply out, and get that we're adding 2x squared. Fractions are now gone. Fractions were eliminated by canceling those factors out. This remaining equation of 10 equals x plus 4 plus 2x squared has to be solved. Recognizing that it's a quadratic, so we need to put it in descending order, and equal to 0. This has to be 0, so I have to move it over. My new equation, doing that, becomes 0 equals, this 2x squared will be first, 2x squared plus this x in descending order and 4 minus 10, -6 or -6. My goal here was to get a quadratic that I can either use the quadratic formula on to solve for x, or in this case I can factor to solve for x. Through factoring I do the MA method, 2 times -6, numbers that multiply to -12 and add to 1, and do it the long way here. Let me move the page up. So the long way, I need numbers that multiply to -12, -12 and add to +1 are 4 and -3. That's 2x squared plus 4x minus 3x minus 6. The GCF for 2x squared plus 4x is 2x. That will be times x plus 2. The GCF for -3x minus 6 is -3 minus 3 times x plus 2. Put it together. This factors into 2x minus 3 times x plus 2. What's equal to that? 0. How do you solve it then? We want to know where 2x minus 3 is 0 and where x plus 2 is 0, giving me solutions of x equals 3/2 or -2. Now, if those are my two solutions, I need to go back and look up at the top there. My extraneous solutions were 0 and 1. Are my solutions extraneous or where it's undefined? No. Then those are my solutions, and I'm done. Solved.